Hello and welcome to part 1 of this e-module on fire systems. The topic of fire systems will be covered in a total of 5 modules, where we will learn all about the different ways of handling fire, firefighting equipment, fire alarms and detection systems, and fixed fire systems. This is the first module of the series, which will focus on fire and portable fire extinguishers. Let's take a look at the learning objectives of this module. By the end of this module, you will be able to define fire, understand fire triangle and fire tetrahedron, list the different stages of fire, explain how to extinguish a fire, classify fire, list the preventive measures to avoid fire, define fire extinguisher, explain how a portable fire extinguisher works, list the parts of a fire extinguisher, explain the types of manual fire extinguishers, explain the impact of fire in business, explain the major causes of fire and preventive maintenance, list the original equipment manufacturers, explain inspection maintenance, hydro testing and period recharging for fire extinguishers, list the maintenance checklist for fire extinguishers, list the top issues and troubleshooting tips. Let us begin with the introduction. Fire plays a major part in our lives, and while it serves us as well as a friend in accomplishing a lot of tasks, yet this great friend can be a very dangerous enemy. A fire in a facility can cause a lot of damage and loss of property as well as human lives, and hence it is important that adequate precautions are put in place to prevent occurrence of fire, and also put in place mechanisms to detect and control the fire in case it does occur despite all the preventive measures. In order to put in place an effective fire safety plan, it is important to understand what fire is, different classes of fire, and what causes and sustains a fire. We will also learn the different principles involved in putting out a fire and other preventive measures to avoid a breakout of fire in the workplace or facilities. In this module, we will learn all about fire and the easiest and handiest or safest ways of handling fires, that is, portable fire extinguishers. We will also learn about the working principle of fire extinguishers, their different types and components. To begin with, let us understand the definition of fire. Fire is the visible effect of the process of combustion. Fire can be defined as a process involving rapid oxidation of substances at elevated temperatures accompanied by the evolution of heated gaseous products of combustion and the emission of visible and invisible radiation. The products from the chemical reaction are completely different from the starting material. The substance, that is fuel, must be heated to its ignition temperature for combustion to occur. The reaction will keep on going as long as there is a supply of heat, fuel and oxygen. This is known as the fire triangle. Now let us understand in detail about fire triangle. The fire triangle has been historically used for symbolizing the process of fire, indicating the 3 essential elements required for a fire to start and sustain. The 3 elements being fuel, something that will burn; heat, to ignite the fuel; oxygen, the oxidation agent. All the 3 components must be available for the fire to sustain itself. The combustion process takes place when fuel reacts with oxygen and heat, in turn generating more heat and flames. The heat generated by the reaction is what sustains the fire. During the chemical reaction that produces fire, solid or liquid fuel is heated to such an extent that it releases gases from its surface. Next, let's understand fire tetrahedron. Fuel can be solids, liquids or gases. The primary modes of firefighting were based on removal of one of these 3 essential elements. In the recent years, another component has been added to explain the concept of fire, and that is the chemical chain reaction. The chain reaction comprises of feedback of heat from the chemical reaction back to the fuel to sustain the fire. Considering this fourth element, now the fire is represented by a tetrahedron, a pyramid with four plane faces, each describing one of the four essential elements of a fire, that is fuel, heat, oxygen, and a chemical chain reaction. This understanding of the fourth element of fire eventually helped in development of fire suppression systems which inhibited the chain reaction to stop the fire. Do you know the different stages fire goes through? Let's have a look. A fire passes through four distinct stages: incipient, growth, fully developed, and decay. Let's understand them in detail. Incipient. This first stage begins when heat, oxygen, and a fuel source combine and have a chemical reaction resulting in fire. This is also known as ignition and is usually represented by a very small fire which often and hopefully goes out on its own before the following stages are reached. Recognizing a fire in this stage provides your best chance at suppression or escape. Growth. The growth stage is where the structures, fire load, and oxygen are used as fuel for the fire. There are numerous factors affecting the growth stage, including where the fire started, what combustibles are near it, ceiling height, and the potential for thermal layering. It is during this shortest of the four stages when a deadly flashover can occur, potentially trapping, injuring, or killing firefighters. Fully developed. When the growth stage has reached its maximum potential and all combustible materials have been ignited, a fire is considered fully developed. This is the hottest phase of a fire and the most dangerous for anybody trapped within. Decay. This is usually the longest stage of a fire. The decay stage is characterized by a significant decrease in oxygen or fuel, putting an end to the fire. Two common dangers during this stage are: first, the existence of non-flaming combustibles which can potentially start a new fire if not fully extinguished. Second, there is the danger of a backdraft when oxygen is reintroduced to a volatile confined space. Next, let's understand how to extinguish a fire. As we have seen earlier, there are four essential elements for sustaining a fire. Removal of any of these four elements can get the fire under control. Therefore, there are four ways to put out a fire. Remove the heat or cool the burning material. Exclude oxygen. Remove the fuel. Break the chemical reaction. Cooling. Removing the heat is one of the most effective methods of fire extinction available. Use of water in fighting a fire is based on the concept of cooling. The fire will go out so long as the heat generated by the fire is less than that which is absorbed by the water or any other cooling agent. Starving. While cooling removes the heat or ignition element of the fire triangle, starving the blaze of its fuel source approaches extinction from a different angle. A raging fire will burn itself out if it runs out of flammable material, that is fuel, such as a bonfire out in the open that isn't in contact with any other wood or dry grass. Similarly, a gas fire will immediately extinguish if the gas supply is cut off. You only have to look at a gas stove or Bunsen burner to see that. Smothering. Smothering involves removal of the third component involved in the chemical reaction that causes combustion: oxygen. For example, smothering a frying pan blaze with a fire blanket reduces the oxygen to below the 16% required to react, while covering a candle with a glass will snuff it out in a vacuum. Interference. Extinguishing the fire by inhibiting the chemical chain reaction at the molecular level is another manner to extinguish a fire. This method is effective on liquid and gas fires. Fires are generally classified based on the fuel type, that is, the material getting burnt. There are 5 classes of fire. Let's look at them. Class A. Class A fires are those involving ordinary combustibles such as wood, fabric, paper, trash, and plastics. Class A fires are commonly put out with water or monoammonium phosphate. Class B. The Class B fire is defined as the type of fire that uses a flammable liquid or gas as its fuel base. Common liquid-based fuel sources include petroleum greasers, tars, oils, oil-based paints, solvents, kerosene, lacquers, alcohols, and flammable gases. Flammable gases such as butane or propane are also common fuel sources of Class B fires. Class B fires are a common hazard in industries dealing with fuels, lubricants, and certain types of paint. Smothering these types of fires to remove oxygen is a common solution to chemical reactions that produce similar effects. Note that fires in cooking combustible media like cooking oil are not included in Class B fires. Class C. The Class C fire is defined as a fire that involves energized electrical or electronic equipment. Electrical fires are often fueled by motors, appliances, and electronic transformers. Electrical fires can occur on smaller scales in all businesses, that is, an overloaded surge protector or bad wiring, and should be taken seriously. To extinguish such fires, cut the power off and use non-conductive chemicals to extinguish the fire. Water being conductive should not be used for these class of fires. Class D. The Class D fires involve a combustible metal as its fuel source. Examples of such combustible metals include titanium, magnesium, aluminium, and potassium. Note that there are also other metals with combustive properties that are used for ignition. Class D fires are a danger in laboratory environments. When confronted with such a fire, common extinguishing agents such as water are ineffective and can be hazardous. To extinguish a Class D fire, use a dry powder agent. This absorbs the heat that the fire requires to burn and smothers it as well. Class K. A Class K fire is defined as a cooking fire involving combustion from liquids used in food preparation. Technically, it is a type of liquid fire. Class K fires are distinct enough to warrant their own classification. Cooking fires are fueled by a wide range of liquid cooking materials. Greases, cooking oils, vegetable fat, and animal fat are all fuel sources found in Class K fires. Class K fires are naturally of concern in the food service and restaurant industry. Such fires can be very dangerous and far more destructive. Wet chemical fire extinguishers have become popular in putting out these types of fires. Next, we will look at the preventive measures that should be taken to avoid fire. Though there are many other aspects of managing fires that we would be learning about later, the following basic measures assist in the prevention of fire. Implement a program that includes preparation, prevention, and recognition of fire hazards. Make sure you practice proper handling and storage of combustible and flammable material. Maintain safe housekeeping practices that reduce the risk of fire danger. Have procedures to cover control of ignition sources like smoking, welding, etc. Always keep adequate fire suppression equipment in your work area to extinguish fire before it goes out of control. Proper maintenance and switching off of heat-producing equipment, including kitchen equipment and electrical appliances. Electrical circuits should not be overloaded. Where required, ground fault protections should be used. Electrical cabling should not have any taped joints. Replace cables when damaged or shaft. Implement fire safety guidelines as per the National Building Code of India. Take regular rounds of the entire facility, including locked spaces. As we have seen, a fire in a workplace can have devastating consequences if not controlled in time. We have also learned that the fire is easiest to control when it is just starting. Hence, it is evident that some means of extinguishing the fire available close by can facilitate control of fire. Portable fire extinguishers serve this purpose. Because of their small size, they can be placed at multiple locations without taking up too much space. They are easy to use and are very effective against small fires or fires in the incipient phase. Different classes of fire need to be handled differently, and hence a range of fire extinguishers have been developed to ensure the most effective action depending on the class of fire. In this module, we will learn about the various portable fire extinguishers that are most commonly used in facilities. Next, let's understand the definition of fire extinguisher. A fire extinguisher can be defined as an active fire protection device used to extinguish or control small fires. A fire extinguisher will usually be portable and comprises of an extinguishing agent stored in a container which is delivered on the fire when the extinguisher is operated. The extinguishing agent could be water, foam, gas, powder, or some chemicals that may cool the burning material, deprives the flame of oxygen, or interferes with the chemical reactions occurring in the flame. The only purpose of a fire extinguisher is to help in extinguishing a fire. However, the way it is achieved may depend on the type of fire extinguisher. Remember the fire tetrahedron. We saw that removal of any one element of the tetrahedron will lead to control of fire. Do you know how a fire extinguisher works? Let's understand. All portable fire extinguishers will deploy one of the methods of extinguishing the fire as described earlier. The working of the portable fire extinguisher is very simple. The extinguisher houses two elements inside the cylinder: the extinguishing agent, the propellant. The propellant is a gas stored at high pressure which, when released by operating a valve or pin, creates high pressure inside the cylinder, pushing the extinguishing agent down and out through a hose at high pressure. Depending on the extinguisher type, a safety pin or clip and a pressure gauge may or may not be available. Now, let's understand the working of a simple water extinguisher with the help of an animation. A ring or pin on the handle stops the fire extinguisher from being set off by accident. It also acts as a tamper-proof seal. If the ring is broken or missing, you know the extinguisher needs to be checked. Inside the sturdy steel case, there is a canister containing high-pressure gas. Most of the extinguisher is filled with water. A tube runs right up the inside of the tube to a nozzle outside. The nozzle often ends in a piece of bendy plastic, so you can easily direct it towards the base of a fire. To operate the extinguisher, you pull the ring and press the handle. Pressing the handle opens a valve that releases the pressurized gas from the canister. The gas immediately expands and fills the inside of the extinguisher, pushing the water downward. As the water is pushed down, it rises up the tube. A jet of water emerges from the nozzle. Let's now look at a carbon dioxide fire extinguisher, which is another type of fire extinguisher used in facilities. The most noticeable difference between a water extinguisher and one that fires carbon dioxide is the large black cone-shaped horn, which allows the carbon dioxide gas to expand, cool, and turn into a mixture of frozen snow and gas. The horn has to be designed very carefully to stop two major potential problems. It has to allow the CO2 to exit at high speed, so any snow that forms doesn't block it up, and it has to mix up the gas in a fairly turbulent way to stop it firing air from the horn at the fire as well, which would effectively make the fire burn more strongly. Now that you have understood the working of a fire extinguisher, let's look at its parts. A fire extinguisher has three main parts: safety pin, handle, and a hose or nozzle. Safety pin. The safety pin is used to prevent accidental discharge. Handle. The squeezing action on the handle activates the propellant by rupturing the canister. Hose or nozzle. This is where the extinguishing agent comes out of. A hose may be used to extend the reach with another nozzle at the end. In CO2 fire extinguishers, the nozzle is replaced by a specially designed plastic horn to cater for the very cold CO2 coming out. The CO2 extinguishers also may not have a pressure gauge. The capacity is gauged by weight. There are different types of extinguishers depending on the type of fire that has evolved. They include dry powder, water, aqueous film forming foam, gas, carbon dioxide extinguishers, dry chemical, wet chemical. Let's look at them individually. Dry powder fire extinguishers are excellent all-round fire extinguishers often recommended for use on vehicles and in the home. All powder fire extinguishers are red with a blue panel, are either ABC or BC rated, and are safe to be used on fires involving electrical equipment. Dry powder fire extinguishers contain an extinguishing agent which is propelled out of the extinguisher body by a compressed, non-flammable gas. The agent forms a blanket over the fire, smothering it and preventing reignition. All used powder residue must be cleaned away and properly disposed of once the fire is extinguished. There are three types of powder fire extinguishers: ABC rated or multi-purpose powder which contain ammonium phosphate, BC rated extinguishers containing potassium bicarbonate or sodium bicarbonate, otherwise known as bicarbonate of soda or baking soda. Some BC rated powder fire extinguishers contain Monix. The pressurizing gas is usually nitrogen. A and D rated graphite powder fire extinguishers are usually used only in Class D fires. The materials used for this type of extinguishers are ammonium phosphate based. The disadvantage of using this extinguisher is its danger of corrosion if the powders are not removed immediately from exposed materials. Monoammonium phosphate is especially likely to form phosphoric acid. Residual powder may cause loss of electrical conductivity as the powders are non-conductive. Water remains one of the most effective fire extinguishing agents we have, from the humble fire bucket to today's more sophisticated water fire extinguishers. Water extinguishers should only be used where they work best on Class A fires, sometimes called ordinary combustible fires. Paper, wood, fabrics, furniture, indeed most things you'll have stored in your home or office will provide the fuel for a Class A fire. Water works in two ways, by both extinguishing the flames and soaking the materials in the fire, cooling them down and preventing them from burning any further. Water conducts electricity, so water fire extinguishers should never be used in a situation where there are exposed live electricity cables or a danger of wiring becoming exposed during a fire. Water mist extinguishers are a recent development that extinguish the fire by taking away the heat element of the fire triangle. They are an alternative to the clean agent extinguishers where contamination is a concern. Water mist extinguishers are primarily for Class A fires, although they are safe for use on Class C fires as well. When sprayed onto a fire, AFFF foam, that is aqueous film forming foam, extinguishes and smothers the flame, then seals in any harmful vapors under the outer film of foam. The foam also penetrates absorbent materials and cools the fire as the water in the foam evaporates. Foam is extremely effective on Class A fires involving paper, wood, etc., so they are a good choice for a general office fire extinguisher, are particularly great on man-made furnishings, where the fibers in the fabrics might otherwise liquefy in the heat of the fires. When used on flammable liquid fires, Class B, the foam forms a film that prevents reignition of the flammable liquids by sealing the liquids away from oxygen in the air. CO2 fire extinguishers, that is carbon dioxide, are the only fire extinguisher recommended for fires involving electrical equipment. CO2 is safe to use on and around electrical equipment as the gas itself is non-conductive, and once used, there is no sticky foam or messy powder left behind. They are also effective on Class B fires, that is flammable liquids. CO2 extinguishers stores carbon dioxide gas under great pressure, 55 bar or 825 psi, where the gas becomes a liquid. When you operate the fire extinguisher levers, the pressure is released. The CO2 pressure is reduced by the diffuser, that is horn, and expands back into a gas, rapidly cooling the surrounding air. This process is so fast, it can cause ice to form on the horn, so never hold a CO2 fire extinguisher by the horn to avoid freezing your skin. To be most effective, a carbon dioxide fire extinguisher should be used no closer than 3 feet and no further than 8 feet from the fire itself. All powder-based specialist fire extinguishers designed for fighting metal fires are categorized as a powder extinguisher, so are colored red with the familiar blue panel above the operating instructions. Dry chemical fire extinguishers extinguish the fire primarily by interrupting the chemical reaction of the fire triangle. Today's most widely used type of fire extinguisher is the multipurpose dry chemical that is effective on Class A, B, and C fires. This agent also works by creating a barrier between the oxygen element and the fuel element on Class A fires. Ordinary dry chemical is for Class B and C fires only. Specialist fire extinguishers for metal fires work by smothering the fire with a non-reactive agent, which forms a crust and excludes air from contact with the metals. Sodium chloride, graphite powder, copper powder are some of the chemicals used. Wet chemical fire extinguishers have been developed specifically for use on deep fat cooking fires. The active ingredient in a wet chemical fire extinguisher is potassium acetate, often added with potassium citrate or potassium bicarbonate. When operated, a wet chemical extinguisher creates a fine mist which cools the flames and prevents splashing. The potassium salts then have a saponification effect on the oil surface, creating a thick, slippery foam layer that smothers the fat and prevents reignition. The chemical foam will also cool the fat over a prolonged period of time. Now let's see how fire can impact businesses. Fire can impact a business in the following ways: major infrastructure and stock loss, lost productivity, psychological impact on occupants, financial losses, fatalities and injuries, staff unemployment, impact on reputation. Major causes of fire or preventive maintenance. Several factors can lead to fire in facilities. Let's look at them and their preventive measures. Next, we will have a look at the top manufacturers of fire extinguishers. Top 5 manufacturers of fire extinguishers are Safex Fire Services Limited, Fire Pro Systems, SafeMax Fire Services, Ceasefire India Limited, Global Fire Protection. Now let's look at the inspection, maintenance, hydro testing and recharging periods for fire extinguishers. Inspection. Monthly inspection of fire extinguishers shall include a check of at least the following items: location in designated place, no obstructions to access or visibility, operating instructions on nameplate legible and facing outward, safety seal and tamper indicators not broken or missing, fullness determined by weighing or hefting, examinations for obvious physical damage, corrosion, leakage or clogged nozzle, pressure gauge reading or indicator in the operable range or position, condition of tires, wheels, carriage, hose and nozzle checked for wheel units, label in place. Next, let us look at the maintenance checklist of fire extinguishers. Procedures shall include a thorough examination of the basic elements of a fire extinguisher, mechanical parts of all fire extinguishers, extinguishing agent of cartridge or cylinder operated dry chemical stored pressure and pump tank fire extinguishers. Expelling means of all fire extinguishers. The detailed procedures for quarterly and annual maintenance can be found at clause 11.13 and 11.14 respectively of IS 2190:2010 with the maintenance checklist of Annexure C of the IS 2190:2010. Maintenance shall be carried out by the manufacturers or their authorized agent or professional firemen. Maintenance is to be performed in full compliance with the maintenance requirements of IS 2190:2010. During the time period that fire extinguishers are removed from service for maintenance or recharge, a replacement fire extinguisher suitable for the type of hazard being protected and of at least equal rating is to be provided. All extinguishers installed in a premise, irrespective of being used in a live fire condition, shall be subjected to an operational test as per the frequency of testing given in Annex D. The operational test should be carried out in such a frequency, keeping in view the frequency given in Annex D of IS 2190:2010 for type of the extinguisher in annually cyclic manner so that all the extinguishers installed in a premise are subjected to discharge test. If more than 10% of the extinguishers subjected to discharge test fail during the test, then all the extinguishers installed in the premises shall be subjected to the discharge test. Let us now look at the lifespan of different types of fire extinguishers. Lastly, we will look at the top issues associated with fire extinguishers that you may encounter and some troubleshooting tips to address those issues. That brings us to the end of part 1 of this module on fire systems. In this e-module, you learned the following: definition of fire, fire triangle and fire tetrahedron, different stages of fire, how to extinguish a fire, classification of fire, preventive measures to avoid fire, definition of fire extinguisher, how does a portable fire extinguisher work, parts of a fire extinguisher, types of manual fire extinguishers, impact on business, major causes of fire or preventive maintenance, original equipment manufacturers OEMs, inspection, maintenance checklist, top 5 issues or troubleshooting.